Sup, it's Jimothy. Today we're going to look at what a piecewise function is, how to interpret it, how it looks like, all that. My voice is monotone. You have to deal with it. So, sucks for you, I guess. So, most piecewise functions, this is just an example, will look something like this. Some of them, instead of having a comma, they will say if x is greater than 1, right? But some will just have a comma in their notation like so. So basically all this is saying, all a piecewise function is saying the graph or the function f at x is equal to these three functions on these three intervals. So just remember, it's just different functions on different intervals. So, for example, on the top, you have f at x equals x squared when x is less than 1, -1, right? Or this can also be written as y equals x squared, if you like that notation better, if that works for you. This next one is f at x equals x when or if x is between or equal to -1 and +1. Again, this can be y equals x, right? And then lastly, we have when f at x is equal to x plus 2, again, when or if x is greater than 1, or again, y equals x plus 2. So this may or may not be helpful, but we'll show you what this looks like. First, we'll look at this top function right here. So, if we were to graph the top function for, we'll call this 1. This is 1, this is 2, and this is 3. So for 1, f at x equals x squared. Now, what does this look like on a graph? If we have our nice coordinate system here, this is x, this is y. This is a very common graph, you'll see this a lot. It looks something like this, right? More symmetrical, better curve, but it's along the lines of this, right? And if we have 2, which is right here, we have f at x equals x, or y equals x. Now, on a graph, that again is a fairly common function, and you'll see it is just a line along the diagonal, right? Because y, a number here, is going to go across and equal a number here, right? So again, if y equals x, it's just going to be like this. So that's that graph. Now, last one, the third one, is f at x equals x plus 2. Now again, this one's pretty simple. This looks like this. So basically, forgot the arrows. This one, this graph here is basically the same as this graph this line, but plus 2, right? So it's parallel. If this is y equals x, this guy, then this guy, it's just x plus 2. So any point here is just plus 2 is up here. So let's say this point is at the level 3, then up here is going to be at the level of 5, because it's just adding 2, right? We'll get that stuff out of the way. And just like that. Okay. But just graphing these doesn't really mean a whole lot, because you have, again, these guys, the domains or intervals in which these functions exist. So for one, this guy, we have x is less than negative 1. So basically what that's saying is, from if this is negative 1, we only want to look at less than. So less than negative 1 is this direction, right? So this whole area going up and over, right? And for the second one, it's negative 1 and x positive 1. Now, just want to redraw that. Now, if negative 1 is here, positive 1 is here, we only want in between the two. So we just want to look at this whole area, right? And then lastly, we have x is greater than 1, right? So if 1 is here, we want more. So we want more, that's this direction. So we're going to look at this area. So now that we have these intervals, we can kind of piece them together as they are pieces in a piecewise function, right? So 1, 2, and 3 equal f at x, right? So the graph is going to look something like so. We'll take piece 1, which is this guy. We only want the part of the graph that's in the yellow. He goes this way forever. So we're going to add him to here. If this is negative 1, she will put him out a bit. So this is negative 1. This is 1. He will be somewhere around here, going up, right? Because this is just the same thing. And then next we have this guy. And so in this interval, we get this line, right? So this line is going to go from negative 1, and we'll just draw these. 1, negative 1. And one thing I forgot, since this guy has the equal sign under, he's going to have a closed circle. So he goes from here to here like such. very bad line. And since this guy on the first graph forgot to say there is no equal sign, he has a open circle. And the open circle just means that the graph has all these points included and goes up to 1, -1, goes up to -1, but does not equal -1. Okay. And lastly, we'll use a red one. This graph is here from 1 and just goes out this way. So this point at 1, he's going to be at 3 because 1 plus 2 equals 3. So he's a bit higher. And again, he's parallel. He's parallel to this guy. He's going out this way. And if you caught my error, he is actually a open circle, right? He is in an open circle because he does not equal 1 right here, but he goes up to 1. So basically, the graph will look something like so, or it won't be in color, so it will look something like such. So if you ever want to draw it or sketch it, you have to first break up into its pieces or functions to sketch out the functions. 3, take sketches on its domain, which this step is right here, where we have the whole function sketched out, yet we only want the function in this area as it's less than -1. So you want to take only the part on the domain, which in this case is in blue. In this case, green and red. And then 4, add on 1 graph. So this is what it looks like in the end. Well, why? And how you deal with a question is, well, there's many types of questions you can have here, but the main thing, if it asks you about certain points, the first thing you have to look at is where is the point, which is here. You have to look in the domain and say, where's the point? If they ask for a point, that's 2, for example. They ask for x at 2. You're going to go to your graph or your piecewise function and say, now 2 is not less than 0, so it can't be the first one. 2 is not between -1 and +1, can't be the second one. And then 2 is greater than 1, so it has to be the third one. So you know, on a graph, you're looking at from around 2 around here. And not graphically, you know you're dealing with the function f at x equals x plus 2, or y equals x plus 2. So there it is, kind of how to sketch a piecewise function and what it means. So basically, in conclusion, a piecewise function is just a group of functions over different intervals. Okay, that's all. Sorry for being boring. Hopefully this helped. See y'all.